Okay, so good morning, class. So in this topic, we will discuss power series. So this is module 9 or ninth week na natin sa numerical methods. Okay, so last module or module 8, nag-discuss tayo ng Laplace transform and solving IVP using Laplace transform. Okay, so for now, ang topic na to is under curve fitting. So, we will use a power series to approximate transcendental function into a polynomial functions. So ano tayo curve fitting. So ito yung topic na to. So curve fitting. Okay, so for power series, so yung power series are the one of the most useful type of series in analysis. So for example, we can use them to define a transcendental function such as the exponential, the trigonometric functions, and many other less familiar functions. So it can also use to a solution to ordinary differential equations. So yung infinite series or any function with which is continuous and is differentiable, the power series is given by f of x equals to c sub 0 x minus a raised to 0 plus c sub 1 x minus a raised to 1 plus c sub 2 x minus a squared plus c sub 3 x minus a cubed plus hanggang c sub n x minus a raised to n. Okay, so um, in using summation from I equals to 0 to infinity, summation of c sub I x minus a raised to I from I equals to 0 to infinity. So we are going to find the constant, yung c, yun yung constants, and yung a is any fixed point of our series. Okay, so ang binanggit kasi dito, that is define daw yung transcendental functions, and we will convert it to parang to define a transcendental function to polynomial functions. So let's say for example we have sine x. Okay, so in order for us to determine if sine x is a continuous function, okay, so and is differentiable, so we take derivative of sine x, okay, f prime of x, that is cosine x, f double prime of x, that is negative sine x, okay, and f third derivative is negative cosine x. And after fourth derivative, okay, after fourth derivative, bumalik na siya sa sin x. So this is a continuous and differentiable functions. So in the power series can transform or can define sin x into a polynomial function. So in order for us to define sin x, so dati kasi yung sin x is sin x is like this curve. So sin 0 is 0. So dito siya nag-start. Okay? Yan. So the power series can define this function sin x into a polynomial function. Let's say this one, c sub 0 x minus a raised to 0 plus c sub 1 x minus a raised to 1, or just simply summation of c sub I x minus a raised to I from I equals 0 to infinity. Okay, so that is the purpose of the power series. So to transform or to define at any transcendental functions to simply a polynomial functions. Okay. So the definition of a power series given in this form, that f of x is equals to this one. Okay. So ito siya. F of x is equals to c sub 0, c sub 1, okay, hanggang c sub n times x minus a raised to n. Okay. So how are we going to find the constant? Okay, paano ba natin hahanapin yung mga constant values na yan? Okay, in order for us to find the constant values, syempre, kung mapapansin nyo to, this is x minus a raised to 0, this is x minus a, Okay, x minus a, x minus a, 3, x minus a sub n. Okay. So, x raised to 0 is 1. Tama ba? So, ito, simplify ko lang to. So, that is f of x is equals to x minus a raised to 0 is 1. So, therefore, that is c sub 0 plus c sub 1 x minus a raised to 1 plus c sub 2 x minus a raised to 2 plus c sub 3 x minus a raised to 3 hanggang c sub n x minus a raised to n. Okay. So how are we going to find c sub 0? Okay. So paano ba natin makukuha yung c sub 0? Ito, this one. So in order for us to define to find the c sub 0, the constant, the first constant or yung c sub 0 is to set any value of a that will make all these terms 0. Ano ba yung ilalagay nating value of x to make all these terms 0? Para matitira na lang f of x and substitute natin yung value of x natin and equals to 0. Okay, kung mapapansin nyo that all terms has x minus a, x minus a, x minus a, and x minus a. Therefore, if we set x is equals to a, all these terms will be 0 and what we have left is c sub 0. So therefore, f of a is equals to c sub 0. Okay? So ganun lang. So next is how are we going to find c sub 1 naman? Okay, how are we going to find c sub 1 naman? So if we take the first derivative of this one, okay, if we take the first derivative of f of x or the power series, that will become, okay, that what is the derivative of c sub 0? Any constant, derivative of constant is 0. Okay, what we have left is c sub 1. Derivative of x minus a raised to 1 is 1. Okay, plus c sub 2 x minus times 2 x minus a. So ito siya. Okay, ito siya. Yan, this one. Yan. Okay, ito siguro. Yan, this one. Ito siya, yung the first derivative. Okay, so derivative of c sub 0 is constant, therefore that is 0. So what we have left is this function. So ganun din. Ganun din yung question. How are we going to find c sub 1 by putting any value of x? Okay, so if we let x equals to a, lahat ng term na to magiging 0. Therefore, what you have left is c sub 1. So that is the solution for c sub 1. Okay, so take the second derivative of the f prime of x, or sorry, take the first derivative of f prime of x or f double prime of x is this one. So derivative of constant, so magiging 0 na siya ngayon. This one, kung mapapansin nyo, this time, nagiging 3 times 2 to. Okay, so nagiging n times n minus 1 to. Okay, so ganun ang concept. Again, how are we going to find the c sub 2 by letting x is equals to a? So mapapansin nyo, naging 2c sub 2. Ito, this one, naging 2c sub 2. Okay, so take the third derivative again. You have this term, and letting x is equals to a, you have this value of c sub 3. So kung mapapansin nyo, if you can see the pattern, okay, so meron siyang 2, sunod 3, 1, may 1 dito, sunod may 2, sunod 3 times 2, sunod 4 times 3 times 2 times 1, sunod 5 times 4 times 3 times 2 times 1. So factorial siya. Okay? So ganito siya. Ito yung pattern. Sorry, yan, this one. So, ito yung pattern. So, f of a is equals to c 0 times c sub 0. Therefore, 0 factorial is c sub 0. 0 factorial class is just simply 1. Okay. So, next is f prime of a or 1 c sub 1. That is 1 factorial c sub 1. So, 1 factorial is 1 again. So, ito rin yung sagot. Okay, f prime of a is 2 factorial times 2 factorial times c sub 2, which is equal exactly the same for this one. Okay, so third derivative of f of x is f of a is 3 factorial c sub 3, this one, and so on and so forth. So ibig sabihin, kung ilan yung derivative mo, yun yung factorial mo dito. Okay, so tingnan natin, i-write natin simply. Okay, so solving for coefficients, okay, divide mo lang to, solving for coefficients. So C sub 0 is equals to f of a 0 factorial, C sub 2, f prime of a 2 factorial, hanggang C sub 5, f the fifth derivative of a and 5 factorial. Okay, so if we write that in initial notation, okay, so f of x is equals to, substitute mo yung value ng c sub 0 na kuha mo, substitute mo yung value ng c sub 1 na nakuha mo. Okay, c sub 2 hanggang c sub n. Okay, so kung mapapansin natin dito, this one is equals to f 1, okay, of a 1 factorial. Dito naman naging f dalawa, okay, second derivative of a over 2 factorial. Okay, hanggang dito sa ilalim, that is f fifth factorial, fifth derivative of a over 5 factorial. So parehas yung ito and this one. So therefore, we can write c sub n is equals to f nth derivative, okay, of a over n factorial. So that is why this one is f of n of a n factorial. Okay? So nakuha ba 'yan? So ayan. So ganyan lang yung ating formula for power series. So this one will we will be using this one most of the time. So itong formula na 'to. Okay, so for the initial notation of this power series, so simply ganito lang siya. So f of a over ith derivative of f of a over I factorial x minus a raised to I, summation from I equals to 0 to n. So this is the formula for power series. Okay, so this is the Taylor series. Okay, so before we start dun sa definition ng Taylor and power, okay, so ito, sinabi ko dito, centered at A. Okay, so ang power series po has two. Okay, they have Taylor and we have Mclaurin. Okay. So ang Taylor class, ang Mclaurin is centered as A equals to 0. So substitute mo lang dito, A equals to 0, that is a Mclaurin series. So the same formula lang po sila. Ang pinagkaiba lang nila is yung center A. Okay? So this is the formula for the power series. Okay? So yes, so let's start the formula for power series. So for power series, the Taylor series of x minus a, this one, okay, pansin nyo, centered at a. So a is not equals to 0. For the Mclaurin series, the same formula, okay, the same formula. Okay, sinubstitute na lang yung a is equals to 0. So dito, a equals to 0, therefore that is 0. And x minus a, so x minus 0, therefore x na lang yung natira. So dito na lang, lalagay ko, this is a is equals to 0, and this one is a is not equal to 0. Okay, so that is a Taylor and power series. Taylor and Mclaurin series. Okay, so before we go to expanding power series, recall some preliminaries. Okay, so I think nalaman nyo to sa senior high school or your junior high school. Okay, so this is let's say a pattern 1, 3, 5, 7, 9, 11, 13, 15, 17. So the question is how to get the pattern. So what is the formula for this pattern? So if you recall your arithmetic series, okay, if you recall the formula in arithmetic series, so ang naka-given dyan sa formula nyo in your junior high school or senior high school, that is a sub n is equals to a sub 1 plus n minus 1 times the common difference. Okay, if you remember, that is the arithmetic series formula. Okay, so gagamitin natin yung arithmetic series na yan to find the pattern para mas madali. Okay, so this one, a sub n is equals to a sub 1 plus n minus 1 times the common difference. Ang starting point lagi niyan is I is equals to 1. So that is simply the same or exactly the same sa ating formula. Sa binigay kong formula na to. That is a sub I is equals to a sub 1 plus I minus 1 times the common difference. So that is starting at a sub 1 and I is equals to 1. If you start, okay, depende kasi yan eh. If you want to start sa I equals to 1 or gusto mo mag-start sa I equals to 0. So it doesn't matter kung saan ka gusto mo mag-start. Ang mangyayari lang if mag-a-adjust ka lang ng polynomial function mo or yung power series mo. Okay? Oh, so ganito 'yon. You will start at I equals to 1 or you can start at I equals to 0. Anything. Pwede ka rin mag-start I equals to 2, I equals to 3. Ikaw bahala. Basta all the terms must be satisfied. Okay? Next is this one. This formula is starting at I equals I sub 0 and I is equals to 1. Okay? So that is the formula. So you can use this formula. I sub I is equals to A sub 0, A sub 0 plus ID, or A sub I is equals to A sub 1 plus I minus 1 times the common difference. Okay, so again, for the sum of arithmetic series, if you can recall the sum of the arithmetic series or infinite series, okay, so we just simply write this one. So I is equals to 1 to infinity, A sub 1, I minus 1 times the common difference. So ito yung ginamit nating formula since ang ginawa ko dito, that is starting at I equals to 1. Okay, I equals to 1. Okay, so so dito sa binigay kong example, that is 1, 3, 5, 7, 9, 11, 13, 15, 17. So we will get the first term. So that is A sub 1, which is 1. Okay, ito yung first term. Then next is I minus 1. Then what is the common difference? So 3 minus 1, that is 2. 5 minus 3, that is 2. 7 minus 5, that is 2. Okay, lahat yan, 2 yung common difference. Okay? So therefore, if we simplify this arithmetic sequence, that is 1 plus 2i minus 2, that is 2i minus 1. Okay? So if you want to start naman sa I equals to 0, okay, papansin nyo that is I equals to 0. So the arithmetic sequence is this one. So A sub 1, sorry, this should be A sub 0. Okay. So first term, yung first term natin, which is 1, okay? Then I, then the common difference, this one, the common difference, which is 2. Therefore, the sum of arithmetic sequence natin using 1, 3, 5, 7, 9 hanggang 1, 2, 3, 5, 7, 9 and so on and so forth, that is 2i plus 1. Summation of 2i plus 1 from I is equals to 1 to infinity. Okay? So that is some preliminaries that we will be using throughout the this topic. Okay? So you will recall the arithmetic series. So ito lang kailangan yung tandaan, these two. Okay? So next is these two will give you the pattern, the formula for the pattern. Okay? So next is recall some preliminaries again. If you see that merong pattern na positive 1, negative 1, positive 1, negative 1, nag-start sa positive 1 na. Okay, positive 1, negative 1, positive 1, negative 1, and n is equals to 0, 1, 2, 3, 4, 5 hanggang so on and so forth. Okay? That is negative 1 raised to n. Okay? So again, if starting from 0, starting from 0, starting from 0, and starting from 0. Okay, so if you see a pattern naman, nag-start ng negative 1, positive 1, negative 1, positive 1, that is negative 1 raised to n plus 1, starting from n equals to 0. Okay, if you see a pattern 1, 1, 2, 6, 24, so on and so forth, that is n factorial. Okay, so this is 4 factorial yung 24. So 4 times 3 is 12 times 2 is 24. Okay, so that is n factorial. If you see this pattern. Okay, so number 4 naman, if you see this pattern, 1, 2, 6, 24, nawala yung isang 1, kaya hindi naging 1 doon. So that is n plus 1 factorial. Okay, so n is equals to 0 hanggang infinity. Okay, so this is the preliminaries that we need to find, to recall in order for us to solve for the power series expansion. Okay, sige. So start na tayo. So representation of function by Taylor and Mclaurin series. So now we will represent a function by the Taylor and Mclaurin series. Okay. So 'di ba sikat na sikat yung ano, yung Taylor version ni Taylor Swift, 'di ba? So may nakita akong isang mathematics page, mathematics meme page. So ito daw yung Taylor version niya. And this one, ito yung Taylor version ng binigay ng isa. So so nakakatawa lang. So ang dito sa isang pictures nakalagay dito Taylor version, yung album. Okay, yung album dito. Tapos yung dito, may Taylor version. Yung Taylor version niya naman is yung Taylor series expansion. This one. This one. Ayan. Ayan. Taylor series expansion. Okay. So, anyway. So, today we will discuss na itong representation of function by Taylor and Mclaurin series. Okay, so first example natin is to determine the Mclaurin series expansion of f of x is equals to e raised to x. Okay, so before we start, we need to determine if e raised to x is a continuous function. Okay, that is a continuous function. First derivative is e raised to x. Second derivative is e raised to x again, so on and so forth, hanggang any derivative ng nth derivative of e raised to x is simply e raised to x pa rin. Okay, so that is a continuous function. Okay, so for the Mclaurin series expansion, okay, so medyo nandito na kasi yung solution. So anyway, so dito tayo mag-start. Imagine nyo na lang na wala pa tong sagot na to. Okay. So nilagay ko dito yung Mclaurin series expansion. That is the formula. F of x is equals to summation of I is equals to 0 and ith derivative of f of 0 over I factorial x raised to I. Okay. So simply, solve lang natin tong f of x. Okay, ito lang yung first move mo. Your first move is simply find the derivative of e raised to x. And kapag may nakita ka ng pattern, tumigil ka na. So most of the time, kapag until f of hanggang fifth derivative, makakakita ka na ng pattern. Okay? So dito kasi makakakita ka talaga ng pattern kasi the first any derivative is e raised to x naman. So f of x is equals to e raised to x. The first derivative is e raised to x. Second is e raised to x. So on and so forth. Therefore, uh, sorry. So therefore, f of n of x is equals to e raised to x pa rin. Okay, now since this is a Mclaurin series, take note, this is a Mclaurin series. A is equals to 0. Therefore, we will use this one. Okay? Ito, uh, f of I, or sorry, derivative of f of 0. Okay? Isa substitute mo yung 0. Okay, therefore, f of 0, e raised to 0 is 1. Okay, f prime of 0, that is 1 again. Okay, 1. Okay, so puro 1 to. Puro 1 to. Okay? So, if we expand that Mclaurin series, okay, balik tayo dun sa Mclaurin series. Okay, asa na to? This one, palitan mo lang yung A ng 0. Okay, expand mo siya na ganyan. Okay, expand natin. Okay, so, sorry. So, expand natin yon. Nasaan na ba yun? This one is f of x is equals to, copy ko lang. That is f of x is equals to, sulat ko na nga. So f of x is equals to c sub 0, f of a 0 factorial x minus a raised to 0. Okay, f prime of a I factorial x minus a raised to I. Okay, so sulat natin yan dito. So that is simply f of a 0 factorial x minus a raised to 0 plus f prime of a 1 factorial x minus a raised to 1 plus f prime double prime of a 2 factorial x minus a squared. Okay? Ayan. Ayan, sige. Sulat lang natin lahat. So yung f of a mo, which is f of 0 for Mclaurin, that is 1. Then over 0 factorial, x minus 0 raised to 0. Okay. Next term naman natin, that is f prime of a, which is 1 over 1 factorial, x minus a raised to 1 plus 1. Okay. Ano ba yung value ng f double prime na natin? So puro 1 pa rin yan. Okay. Ito yung value f of a. This one is the value of f prime of a. This one is the value of f double prime of a, f triple prime of a, and f fourth prime of a. Okay, or fourth derivative of a. Okay, so substitute mo lang x minus, what is your a? 0, 0, 0, then 0 factorial, 1 factorial, 2 factorial, 3 factorial, and 4 factorial. Okay, sorry. So simplify natin para makakita tayo ng pattern. So x minus 0, lahat yan naging x lang. X raised to 0 over 0 factorial. Next one is x raised to 1 over 1 factorial. X raised to 2 over 2 factorial. X raised to 3 over 3 factorial. And x raised to 4 over 4 factorial. And so on and so forth. Okay? So if we start from I is equals to 0. Okay, I is equals to 0. Okay. So if start and I is equals to 0, it just simply this one, I factorial. So bakit naging I factorial? Kung hindi mo napapansin agad, syempre I equals to 0, substitute mo dito. So that is 0 factorial. Next term, magiging 1 factorial. Next is 2 factorial. Okay, 3 factorial. Or if you hindi mo siya naguguluhan ka, bakit naging I factorial yan? You can use the arithmetic series or arithmetic sequence na binanggit ko sa preliminaries. Okay? So that is simply from starting from I equals to 0. That is simply a sub 0 plus id. Okay? A sub 0 plus id. So if we start from a is equals to 0, that is a sub n is a sub I is equals to a sub 0 plus id. Okay, what is our first term? That is 0. Ano ba yung common difference natin? That is 1. Okay? So therefore, a sub I is equals to 1. Is equals to I. So ito yun. Kaya siya naging I factorial. So yan yung pattern for 0, 1, 2, 3, 4, 5. So ganun din yung sa taas 0, 1, 2, 3, 4, 5 hanggang n. So that is simply f of x is equals to the summation of x raised to I over I factorial from 0 to infinity. On this one. So next, if you want to start from I is equals to 1, kung gusto mo naman mag-start sa I equals to 1, gamitin mo lang din yung arithmetic series para hindi ka na malito. If you, kung nalilito ka, bakit I minus 1 factorial to? So for starting, sorry, bakit ko binura yun? Okay. Okay. So if we start from I is equals to 1, okay, so simply ganito yan, di ba? A sub I is equals to A sub 1 plus I minus 1 times the common difference. Okay, the same. A sub I is equals to what is the first term? That is 0. I minus 1. What is the common difference? That is 1. Okay, so therefore, that is I minus 1. Okay, so ganun lang. So the same din naman yung taas, 0, 1. Kung ano yung nasa baba, yun din yung nasa taas. Therefore, if f of x is equals to the summation of x raised to I minus 1 over I minus 1 factorial from I is equals to 1 to infinity. So that is the Mclaurin expansion for e raised to x. Okay, so that is the Mclaurin series expansion for e raised to x. Okay, so please recall, tawag dito, please memorize this Mclaurin expansion para hindi na kayo mag-solve for e raised to x. Kasi magagamit natin tong e raised to x na to sa other functions. So mamaya madidiscuss natin how to use yung known Mclaurin series expansion to other Mclaurin series expansion. Okay, so this is e raised to x. Okay. So do you have questions for this class kung paano ito nakuha? Okay. Wala naman.
None po.
Okay. Sige, next problem natin is find the Mclaurin series expansion of f of x is equals to sine x. So before we start, again, sine x is a continuous function or a infinite function dahil take any derivative. Okay, paulit-ulit lang siya, hindi siya magiging zero. Okay, so, unlike polynomial kapag pababa yung powers. Okay, so that is sine x. Sige, solve natin yung sin x. Okay, so never mind this muna. Okay, wala muna to. Dito muna tayo sa gilid. Okay. So ito yung first move natin. Yung first move natin is find a pattern of f of x. Okay, so find the pattern of f of x or f prime of x or n prime of x. Sige. So first derivative natin is cosine x. Okay. The second derivative is negative sine x. Derivative of cosine x is negative sine x. Okay, then the third derivative, negative sine x, so that is negative cosine x. And derivative of negative cosine x is sine x. So bumalik na siya dito sa original function. So if you further take the fifth derivative, babalik ka dun sa pattern cosine x, negative sine x. Ay, sorry. Bakit ganito? Okay, negative sine x and cosine x. Sorry, negative sine x, negative cosine x. Then babalik ulit sa pattern. Okay? So, yun nga, sinabi ko nga, hanggang typically niyan hanggang fifth derivative or fourth derivative makakahanap ka na ng pattern. Okay, now so since that is a Mclaurin series, okay, this one Mclaurin series, ito. So we will substitute a is equals to 0. So therefore f of a is equals to 0. F of 0 is equals to 0. Substitute nyo lang dito. Sine of 0 is 0, cosine of 0 is 1, negative sine of 0 is 0, negative cosine of 0 is negative 1, and sine of 0 is 0. Okay? So ito yung ating f prime of 0. f raised to ith derivative of 0. Okay, now pasok natin siya dun sa sa power series expansion. So power series expansion, that is f of 0 over 0 factorial x, this one. So hindi ko na ilalagay yung x minus a. So ito na siya, x sub 0 plus f prime of 1 factorial x raised to 1 plus f prime of, bakit 1 to? 0 to dapat. F double prime of 0 over 2 factorial x raised to 2 plus yan. Okay, papansin nyo, that is simply ito lang. In-expand ko lang siya. Starting from 0, next is 1, 2, so on and so forth. Now, substitute natin lahat tong nakuha natin dito sa kabila. Okay, if we substitute, that is 0. F of 0 is 0 over 0 factorial, x raised to 0. Next is f prime of 0, which is 1 over 1 factorial, that is 1. Okay, next is f double prime of 0, that is 0 over x squared times x squared over 2 factorial. Then next is negative 1x cubed over 3 factorial. And f of 4 is 0, x raised to 4 over 4 factorial. Okay? So hanggang dito. Nakakita ka na kasi ng pattern eh. Okay, so umulit siya. Okay? So if we simplify this one, so it just simply any number multiplied by 0 will be 0. This one will be 0. This one will be 0. So what you have left is this one. So 1x raised to 1 over 1 factorial minus 1x raised to 3 over 3 factorial plus, ano sa tingin niyo yung sunod dito? Sunod dito, syempre, that is 1x raised to 5 over 5 factorial. Sunod dito is negative 1x raised to 7 over 7 factorial. Okay, and so on and so forth. So Alam nyo na, nakakita na kayo ng pattern. So, ibig sabihin, yung pattern is 1, 3, 5, 7, 9, 11, 13, 15, 17, so on and so forth. Okay? So, if we go back to our preliminaries, okay, that is yung binigay ko kanina. Yan din yung binigay ko example kanina. 1, 3, 5, 7, 9, 11, 13, 15, 17. Okay, so ito siya, 2i minus 1 and 2i plus 1. If we start from, this should be I equals to 0. I think I have some typographical error. Okay. So, if nag-start tayo ng 1, that is 2i minus 1. If nag-start tayo ng 0, that is 2i plus 1. Okay. So, balik lang natin dito. So, the formula, okay, the formula if starting from I is equals to 0, this one, okay? And the formula for starting at I is equals to 1 is this one. Okay? Ito yung recall sa preliminaries natin. And if you note that positive yung first term, sunod negative yung first term, sunod positive again, negative, positive, positive, negative. So, ibig sabihin that is simply 1, negative 1, 1, negative 1, or just simply negative 1 raised to n starting from, this will start from n is equals to 0. Okay? So, ito siya. If you recall, baka nakalimutan niya na agad. So, ito siya. Negative 1 raised to n. Okay, this one. Okay? So, ayan. So, pwede na nating isolve. Pwede nating isulat kasi may pattern na tayo eh. So, yung I, yung mga 1, negative 1, 1, negative 1, we can write it as negative 1 raised to n or negative 1 raised to I. Ito siya. Negative 1 raised to I. Yan. So, yung mga ano naman, yung mga powers ng x and the factorial. So, ito yung pattern. 1, 3, 5, 7, 9. So, 1, 3, 5, 7, 9 hanggang ano. So, na-recall natin that is the formula 2i plus 1 when starting at I is equals to 0 and 2i plus 1 when starting at I is equals to 0 nga. Sorry. So, ito yun eh. So, ano ba yung a sub 0? That is 1 plus I times the common difference 2. So, that is therefore 2i plus 1. Okay? Ito yan. So, ito yung answer. So, ito na yung answer natin. So, therefore, sine of x is approximately negative 1 raised to I, x, 2i plus 1 over 2i plus 1 factorial, summation from 0 to infinity. So, ito yung sine of x, power series, Mclaurin series expansion of sine of x. So, if you want to start naman at I equals to 1, okay, meron kasi mga book na nag-start sila sa I equals to 1 always, and consistent sila sa I is equals to 1, and consistent sila minsan sa I equals to 0. So, it doesn't matter kung saan ka mag-start. Basta parehas yung all the terms must be satisfied. Okay? So, dito naman, since mag-start tayo sa 1, okay? So, since mag-start tayo sa 1, therefore, yung negative, yung pattern natin na 1, negative 1, 1, negative 1 will be negative 1 raised to I minus 1. And yung powers ng x natin, 1, 3, 5, 7, 9, if we start from I is equals to 1, that is this formula, a sub 1 plus I minus 1 times the common difference. So 2i minus 1 over 2i minus 1 factorial. So ito yung ating 2 Mclaurin series expansion starting from I is equals to 0 or starting from I is equals to 1 of sine of x. Okay, so may question ba kayo dito, class?
None po.
Okay, sige. So next natin is ayun. So dagdag ko na lang din to sa you need to memorize. Okay, you need to memorize e raised to x and you need to memorize sine of x. Okay? So that is my advice. You need to memorize the X series Taylor series expansion for e raised to x and sine of x. Okay? So next natin is example 3, which is 1 over 1 minus x. Okay, so this is also a continuous function. So mamaya di-discuss natin bakit siya continuous function. Okay, this one. So yung 1 over 1 minus x is just simply 1 minus x raised to negative 1. Tama ba? That is 1 minus x raised to negative 1. Okay? So if you take the first derivative, that is negative 1 times negative 1. So they magiging positive 1 minus x raised to negative 2. Then take the second derivative, that is 2, 1 minus x raised to negative 3. And take the third derivative, that is 6, 1 minus x raised to negative 4. Okay? So, hindi ko na siya tinuloy kasi napapansin ko that always may 1 minus x, nagbabago lang ito, and ito. And this one is may nakita akong pattern agad. 1, 2, 6. Ano ba yung nakita niyong pattern? May start pa pala, sorry. Nag-start sa 1, nag-start sa 1, 2, 6. Okay? If you see a pattern, ito yung binigay ko sa inyong preliminaries. That is 1, 1, 2, 6, 24. That is simply at n factorial. Okay? That is simply n factorial. Ito kasi is 3 factorial, equals siya sa 3 factorial. This one is 2 factorial, this one is 1 factorial, and this one is 0 factorial. Okay? So that is why ito siya. So 1 is equals to 0 factorial, dito siya, f of 0. Next is f prime of 0, which is 1. Okay, hanggang 24. Okay? So simply, nakakita ko ng pattern na that is a factorial. Okay? So, using a Mclaurin series expansion, since that is centered at a equals to 0, okay? So, simply, pasok mo lang siya dito. That is 1, 1, 2, 6, so on and so forth, 0 factorial, 1 factorial, 2 factorial, 3 factorial, and so on and so forth. Okay, so therefore, we can say that this one, okay, so 1 over 1 minus x is simply summation of I from equals to 0 or from infinity. Okay. Kung mapapansin nyo, class, nakaka-cancel ito. Oh. Hindi ko pala nasabi. Nakaka-cancel ito and ito. Nakaka-cancel ito and ito. Okay, cancel ito and ito. Okay. So may factorial ka sa taas, may factorial ka sa taas. So ibig sabihin nakaka-cancel yung numerator and denominator. So what you have left is yung powers na lang ng x. Okay? So therefore the Mclaurin series expansion of 1 over 1 minus x is simply x raised to I from I is equals to 0 to infinity. Okay? And pwede rin siya na x raised to I minus 1 from I is equals to 1 to infinity. Okay? So this one is the Mclaurin series expansion of 1 over 1 minus x. So this is you need to memorize then. Okay? Para mas madali yung buhay nyo. Okay, ito. So you have 3 para mas madali yung buhay nyo. You have your e raised to x, sine of x, and 1 over 1 minus x. Okay, so for the common Mclaurin series expansion, you need to remember is this one. E raised to x, sine x, and 1 over 1 minus x. So sinulat ko na siya dito para hindi na kayo problema. Okay, bakit may ganito dito? Okay. Yan. So, ito yung kailangan nyo i-remember all the time. Sige. So, for Mclaurin series expansion of another problem that is 1 over 1 plus x. So, this solution, nagagamit tayo ng ito, yung common series natin. Yung yung mga formula, yung mga common series expansion na alam na natin. Okay? So, ito yung gagamitin nating solution dito. Hindi na tayo gagamit nitong mga to. Okay. So, for example, number 4, that is 1 over 1 plus x. Okay. So, yung other solution natin by using a common Mclaurin series. So, if you take note, this one, 1 over 1 minus x is, the Mclaurin series expansion is x raised to I from I is equals to 0 to infinity. So, ito lang yung example 3 natin kanina. Okay. So, we can write 1 over 1 plus x by simply 1 over 1 minus negative x. So, pinagmukha lang natin siya na ganito. Ang x mo lang is naging negative x. Okay, pinagmukha mo lang na ganito. So, we can change x to negative x. So, paltan mo lang yung x dito. Paltan mo lang yung x dito. Naggawin mo lang siyang negative x. Okay? So, now you have your, ito na yung answer mo. So, the Mclaurin series expansion of 1 over 1 plus x is simply negative x raised to I from I is equals to 0 to infinity. So, you can expand the negative x is parang ganito lang din yan eh. Negative x raised to I is equals to negative 1 times x raised to I. So, negative 1 raised to I, x raised to I. Ayan. Ayan. So, this one is the Mclaurin series expansion of 1 over 1 plus x. So, ganun lang. Kaya ako pinapasaulot sa inyo tong 3 common series expansion para magamit natin sa solution dito. So, imagine if you go to this direction pa rin ng pag-solve. So, makakakuha ka pa rin naman ng answer. But, sinabi ko nga, you can use the common Mclaurin series. Okay, next. Next problem is this one. 1 over 1 plus 4x. Okay, kapag nakakita ka ng itsurang ganito, automatically that is, we can write it as this form. Okay, so take note that this is yung recall natin na common Mclaurin series. Okay, so if you write 1 over 1 plus 4x into something familiar or somewhat similar to 1 over 1 minus x. So that is simply 1 minus negative 4x. Okay? So yan siya. So kinulayan ko lang siya ng red. Ito yung dating x mo. So pasok mo lang siya dito. Okay? So that is simply this one. So negative 4x raised to I. Okay? So simplify mo lang further. Okay? Negative 4x raised to I is simply ganito. Negative 4 multiplied by x raised to I. So magiging negative 4 raised to I. Distribute I power x raised to I. And negative 4 pwede mo siyang i-rewrite as negative 1 times 2 squared, di ba? So that is negative 1 raised to I 2 squared times 2 times I, that is 2I x raised to I. So that is simply, ito yung answer. Oops, bakit ganyan? Hirap talaga pag ayan. Ayan. So that is, pwedeng ito yung answer mo. Oh, don't worry, pwede na yan. Tatanggapin ko rin yan. Or pwedeng ito. Negative 4 raised to I over times x raised to I, or simply negative 1 raised to I 2 raised to 2I x raised to I. So starting from I is equals to 0 to infinity. I is equals to 0 to infinity. Okay? So next Mclaurin series is this form. So 5x. So find the Mclaurin series. Expansion of 5x over 4x squared minus 5x plus 1. Okay? So ito yung Mclaurin series. So other solution is by using a common Mclaurin series. So take note that ito yung gagamitin natin. This one. Okay? So if you take the partial fraction, okay, I think that right now alam niyo na yung paggamit ng partial fraction, okay? So that is yung Laplace transform na ginamit natin. So magagamit natin yung Laplace partial fraction sa solving Laplace transform and this one. Okay? So sige, if you recall partial fractions, sige, solve ko na lang din dito. So that is 4x minus 1, x minus 1. Okay, so that is simply a 4x minus 1. Kailangan 1 ano lang, 'di ba? 1 degree yung lower yung numerator sa denominator. So that is b over x minus 1. So kapag ganito yung powers of 1 lang, substitute mo lang yung a is equals to magpapasiro sa ilalim, that is a is equals to 1/4. Then dito is x is equals to 1/4 to solve for a. and x is equals to 1 to solve for b. Okay? So just simply ganito. 5/4 over 1/4 minus 1 is negative 5/3 yung A, and yung B natin is 5/3. So therefore, okay. So therefore, yung original series natin na f of x will be this one. Negative 5/3, 1 over 4x minus 1 plus 5/3, 1 over x minus 1. Okay. So we will rewrite 1 over 4x minus 1 to somewhat similar to 1 over 1 minus x. So paano mo ba i-rewrite yung 1 over 4x minus 1? So you can rewrite 1 over 4x minus 1 to negative 1. Okay, so sulat ko dito. 1 over 4x minus 1, you can rewrite it as negative 1. Sorry, dito na lang sa ilalim yung negative para mas makita. Negative 1 minus 4x. Okay? So, negative, that is positive, negative 1, negative times negative, that is positive. So, ito siya. So, nire-write natin yung 4x minus 1 into 1 minus, negative 1 over 1 minus 4x. So, since negative times negative, magiging positive 5/3 na to. Okay? So, the same to 1 over x minus 1, kailangan nating i-write na somewhat familiar to similar to this one. So 1 over negative 1 minus x. Okay? So therefore, yung positive 5 over 3 naging 5 negative 5 over 3 na lang. And what you have left is 1 over 1 minus x. So same method dito. So 4x, substitute mo yung 4x doon. Okay? So that is 4x minus raised to I. Then this one is x raised to I. Okay, simply the same. So I think this should be 1 plus 4x. This should be positive. This should be positive, sorry. Yan. Yan. So positive 4x raised to I. Sorry, typographical error. Sige, i-note ko na lang to. Pati, asan ba yung typo ko? Wala. Ayan. So that is Mclaurin series. So you will use partial fraction expansion to your original function para mas madali mong makita kung paano mo siya i-convert into a common Mclaurin series. Okay? So another problem, another Mclaurin series expansion is, for example, f of x is equals to e raised to x squared. Okay, if you take note that e raised to x is equals to x summation of x raised to I over I factorial starting from 0 to infinity. Okay, so simply change mo lang yung x into x squared. Okay, palitan mo lang yung x ng x squared na to. So, ito, kaya ko siya inibang kulay, that is this one, x squared, x squared. Okay, so therefore, x squared multiplied by raised to I, that is x raised to I. Di ba? Kapag a raised to b multiplied by c, that is simply a raised to bc. Okay, nagmo-multiply yung powers. Okay, if you recall your this one. So that is simply e raised to x squared is approximately summation of x raised to 2i over I factorial starting from I is equals to 0 to infinity. Okay, so this is the final answer for this Mclaurin series expansion. Okay, so operations involving the power series. So before we start, do you have questions for this one? Yung solution by using common Mclaurin series.
None po.
Okay. So the question is, paano kung wala dun sa hindi mo maihawig dun sa common Mclaurin series? So the worst, hindi naman siya worst eh. So the solution will be going to this form, yung magaganto ka. Hahanap ka ng pattern, you will expand, ganyan. Magaganto ka. Kapag hindi mo siya nahihirapan kang i-transform into a common Mclaurin series expansion. Okay. So for operations involving the power series, so meron din siya mga operations, may mga plus, minus, times, divide, basic operations involving the power series. So for the operations involving the power series, so let's say this one, f of x, ito yung f of x natin, let's say ito yung g of x natin, ito yung h of x natin. So ito yung mga power series expansion natin, for example ha, example lang. So let's say for addition and subtraction, sorry, f of x is plus g of x is just simply this one. So pwede mo siyang kapag may parehas sila na parehas sila ng powers, you can add them and form ai plus bi equals to x sub I. So pwede mo silang i-transform to that. Basta parehas sila ng powers ha. Basta parehas sila ng powers. Kahit man mag-plus yan or mag-minus yan, basta parehas sila ng powers, you can add them. Okay? Next naman is by differentiation. Okay, so the derivative of your f of x, derivative of f of x is equals to the derivative of the power series expansion. So the same lang yon. Let's say the derivative of your okay, sorry. So f of x, sorry. Let's say for example, you want to find the Mclaurin series expansion for cosine x. So you know the Mclaurin series expansion for sine x, di ba? So ito siya. Let's say ito siya, di ba? Yan. So if we all know that the derivative of sine x is cosine x pa rin, so d over dx ng sine x is equals to d over dx din ng kanyang power series. Okay? So that is the operations involving your power series. If you take the derivative of the function, the continuous function, that is simply equal to the derivative of its power series. Okay? So the same with integration. If you take the integration or the integral of your f of x is equals din siya sa integral of the power series expansion. Okay? So that is the problem. So we have a problem. Let's say you have a cosine hyperbola of x. So f of x is equals to the cosine hyperbola of x. So if you recall the cosine hyperbola of x, that is simply e raised to x over plus e raised to negative x over 2. So that is the cosine hyperbola of x. So for cosine hyperbola of x, that is e raised to x plus e raised to negative x. So sulat lang natin sila isa-isa. So gagamitin natin yung operations involving power series. Okay. So yung e raised to x class, that is, alam na natin, that is x raised to I over I factorial starting from 0 to infinity. So that is a common series, di ba? Common series, common Mclaurin series yan na pinasaulo ko sa inyo. Next one is e raised to negative x. So yung e raised to negative x, just simply paltan mo lang yung x ng negative is this one. So summation of I equals to 0 negative to infinity of negative x raised to I over I factorial. So no problem ka dito and this one. Okay? So pwede mo na siyang ilagay dito. Dito. So if you take, so parang ganito siya eh. E raised to x of plus e raised to negative x over 2, that is simply your cosine hyperbola of x. Ito, that is your cosine hyperbola of x, or that is your original function. Kinonvert mo lang siya into Euler's number. Okay, so e raised to x plus e raised to negative x over 2, that is equals to 1/2 summation of your first power series ng e raised to x, that is x raised to I over I factorial, and the power series of your e raised to negative x, that is negative x raised to I over I factorial. Okay, so just simply this one. So simplify lang natin para mahiwalay natin, para maparehas sila natin ng powers. So x raised to I factorial, so yung negative x raised to I is simply negative 1 times x raised to I magiging negative 1 raised to I x raised to I. Kaya ito siya. Negative 1 raised to I, x raised to I. Okay? Yan. So, therefore, parehas na siya ng x ng powers. X raised to I, x raised to I. So, now, we can add them. So, pwede na natin silang ipag-add. Okay? So, if we add them, so 1, this one, 1 minus negative 1 raised to I. So, 1 plus negative 1 raised to I, x raised to I over I factorial. Okay? So, ito na siya. So, ito na yung answer mo. Okay? Ito na yung answer mo. Pwede na yan. However, if you want to be more simplified version, mas simplified yung terms, so expand mo siya. Expand mo siya ng konti. So let's say this one is your I is equals to 0, I is equals to 1, I is equals to 2, I is equals to 3, and I is equals to 4. Okay, if we substitute I is equals to 0 in this term, that is 1 plus 1, that is 2, x raised to 0 over 0 factorial. If we substitute I is equals to 1, okay, so 1 minus 1 is 0. So anything multiplied by 0 is 0. Next is if we substitute I raised equals to 2. Okay, I is equals to 2. Negative 1 raised to 2, that is positive 1. 1 plus 1, that is 2. X raised to 2 over 2 factorial. I equals to 3, ito. And I is equals to 4, ito. Okay, if you simplify, x raised to 0 is this 1. So substitute mo yung 1 half. Pasok mo yung 1 half dyan. So that is x. Maka-cancel yung 2. So therefore, that is x raised to 0 over 0 factorial plus maka-cancel yung 2, maiwan yung 2 factorial. Then this one, maka-cancel yung 2, maiwan yung 4 factorial, so on and so forth. Okay? So meron ka nang nakitang pattern, that is 0, 2, 4. Doon din yung ilalim, 0, 2, 4. So, as you can see, that is an arithmetic series. Okay. So, arithmetic series nga, di ba, ang formula natin, if we start from I is equals to 0, that is A sub I is equals to A sub 0 plus ID. Okay. So, ano ba yung first term natin? That is 0. Ano ba yung common difference natin? That is 2. Therefore, A sub I natin is equals to 2I. So that is why 2I yung ginamit ko dito. Okay? So that is x raised to 2I over 2I factorial starting from 0 to infinity. So yan yung power series expansion for cosine hyperbola of x. So imagine you can use a common Mclaurin series expansion and use operations to solve for cosine hyperbola of x. Mas madali. Okay? So do you have questions for this example problem?
Ano po?
Okay, thank you. So next natin is example natin is cosine x. Okay, this one. So gagamitin natin yung powers operation na to. So di ba din-discuss ko kanina? Okay. Ayan. So in traditional solution, okay, traditional muna tayo. Traditional solution, you want to take first derivative of cosine x, that is sine x, hanggang sa may makita kang pattern, di ba? So cosine x, negative sine x, negative cosine x, sine x, then yun, bumalik na sa cosine x. So you have a pattern na. So now, if you take a is equals to 0, since this is a Mclaurin series, so ito yung f of prime of 0, f of 0 is equals to 1, f double prime is negative 1, 0, 1. Okay? So using a Mclaurin series expansion, this one, okay? So 1 times x raised to 0 over 0 factorial, so on and so forth. Yan. This one. Expand lang natin siya. And you can see a pattern. May pattern kang nakita. The pattern is 1, negative 1, 1. Okay, 1, negative 1, 1, 1. Then the pattern is 0. Ito, magiging cancel to eh. Cancel, cancel. So, naging pattern na nakita mo is 0, 2, 4, 6, 8. 0, 2, 4, 6, 8, 10. Hanggang ganun. So, starting from yung formula natin, starting from I is equals to 0. So, A sub I plus ID, that is simply A sub I is equals to 0 plus 2i. Okay, a sub 0 natin is 0. The first term is 0 plus 2 times I. The common difference is 2, then I. Okay, so that is your term. Okay, so since ito is positive 1, negative 1, that is simply negative 1 raised to n. Starting at, sorry, hindi ko nasulat dito eh. This should be start at n is equals to 0 then. Okay, so therefore, the traditional solution, our traditional solution for the Mclaurin series expansion of cosine x is simply this one: negative 1 raised to I x raised to 2i over 2i factorial. Okay, so ito yung traditional solution. If we use the basic operations, okay, so from the operation number 2, the differentiation, we all know that the derivative of, so bago ka mag-start dyan, ano lang ba yung alam mong preliminaries? Ang alam mong preliminaries is sin x, e raised to x, and 1 over 1 minus x. So sin x lang yung meron ka, cosine x yung binigay na problem sa'yo. So you can use a differentiation. So you all know that the differentiation or the first derivative of cosine x is simply negative sin x. So pwede ka nang gamitin to. Pwede mo nang gamitin to. Kailangan mo lang ang i-take the first derivative ng Taylor series expansion niya. Okay? Ayan. So, that is the solution. You will use operations. Okay, so ganito. Balik tayo dito. So, as we all know that sine of x is equals to negative 1 raised to I, x raised to 2i plus 1 over 2i plus 1 factorial, starting from 0 to infinity. So, from the basic operations, the taking derivative of the function is equals to taking the derivative of the power series expansion. Okay, so ganun yung gagawin natin. So cosine x is simply the same as derivative of sine x. Derivative of sine x is equals to the derivative of that the power series expansion of sine of x. Okay, ito siya. So taking the derivative of this one. So paano ba kukunin yung derivative nito? Okay. So paano ba kukunin yung derivative nito? Okay? Ganito 'yan. Since we are dealing with dx, okay, dx. So anything na hindi x is constant. Okay? Anything na hindi x is constant. So therefore, the only term that are differentiable is this one. Ito lang yung differentiable. Tama ba? That is the differentiable. So if you recall, derivative of x raised to n, okay, derivative of x raised to n is equals to bababa mo yung n, then x raised to n minus 1. So that is this one. Okay? Ngayon, kung babalik tayo dun sa ating example, which is x raised to 2i plus 1. Okay? So derivative, so ibaba mo yung 2i plus 1. Okay? 2i plus 1. Then, x raised to 2i plus 1 minus 1. Okay? Therefore, that is 2i plus 1 x raised to 2i. Okay? So, yan yung ating power series expansion. That is the derivative of your power series. Okay? So, 2i plus 1, x raised to 2i, and all this term is left hindi ginalaw. Kasi that is a constant. Ito. Hindi yan ginalaw. Kasi that is a constant. Okay? Yan. Yan, para medyo malinis. Okay. So yan na, meron na tayong first derivative or the derivative of your Taylor series, of your power series expansion for sine x. So ito na yung power series expansion ni cosine x. Di ba? Yan na yun. However, if you want to be more simplify yung version, so simplify lang natin. Okay? So, negative 1 raised to I, 2i plus 1, x raised to 2i over 2i plus 1. Pwede mo siyang i-rewrite as this one. So, negative 1 raised to I, 2i plus 1 x raised to 2i over 2i plus 1 times 2i factorial. So bakit ako nag 2i plus factorial dito? Okay. Para ma-cancel ko yung 2i plus 1. Gusto ko na ma-cancel to eh. Medyo mahaba yung numerator. So paano ko ba maka-cancel yun? So, 'di ba? If you want if your term is 2 factorial, okay, ganyan. Ito, sorry. Ito pala. If you try 6 factorial, this one, 6 factorial is simply 6 times 5 times 4 times 3 times 2 times 1. Tama? Okay. Yung 6 times 5 times 4 times 3 times 2 times 2 times 1, pwede mo siyang i-rewrite as 6 times 5 factorial. Tama ba? 6 times 5 factorial. So, ganito yung gagawin ko dito sa denominator ko. Yung 2i plus 1 is simply 2i plus 1 multiplied by 2i. Kasi this one, kasi yung 6 ko, ginawa kong minus 1, naging 5. So, yung 2i plus 1 ko, lagyan ko ng minus 1, that is 2i. So, therefore, ganito rin yung nangyari dito. So, 2i plus 1, this one, 2i plus 1 over 2i factorial. So, pwede ko na ngayon ma-cancel si 2i plus 1. This one. Pwede ko na ito ma-cancel and pwede ko na ito ma-cancel. What I have left is 2i factorial. So, therefore, the Mclaurin series expansion for cosine x is simply negative 1 raised to I x raised to 2i over 2i plus 1, 2i factorial, starting from I is equals to 0 to infinity. So, that is the solution. Okay? So, ganyan lang yung mag-differentiable. The only terms that are differentiable is yung my x. Okay, take note. The only term that is differentiable is my x, yung my x term or my constant na x. May variable na x, sorry. Okay? Sige. So, next problem is this one. So find the Mclaurin series expansion of 1 over 1 minus x squared. So as we all know, if the derivative of 1 over 1 minus x, okay, derivative of 1 minus 1 over 1 minus x, okay, that is negative 1. So taking the derivative of this one, so derivative nito is simply negative 1, 1 minus x raised to negative 2. So parang mangyayari that is simply negative 1 over 1 minus x squared. So halos parehas na siya dito. May negative lang, di ba? Okay? So I think dapat may negative to. So may typographical error din dito. Okay. Yan. So taking the derivative of 1 over 1 minus x is simply 1 over 1 minus x squared. Okay? So, pwede mo nang gamitin ito. 1 over 1 minus x. So, taking the derivative of this one, we can say that this should be negative 1. Sorry for this. Yan. Okay. Okay, sige. This one is negative. Yan. May negative 1 din dito. Ay, sorry. Tama nga, positive pala. Kasi derivative of 1 minus x is negative 1. Sorry. So, sorry. So, hindi siya pala typographical error. Okay? Kasi nga pala, ang derivative ng 1 minus x raised to negative 1, negative 1. So, derivative is negative 1. Then, 1 minus x squared, negative 2. Then, derivative of 1 minus x is negative 1. So, equals din siya sa 1, positive 1 minus x squared, negative 2. That is simply 1 over 1 minus x squared. So, hindi pala typo. Sorry. So, ito yung answer dito. So, taking the derivative of both sides, therefore, that is 1 over 1 minus x squared, derivative of x raised to I. So, x raised to I is a differentiable since we are derivative differentiating pala. We are differentiating with respect to x. So x raised to I, derivative of x raised to I is simply I x raised to I minus 1. Okay? So ito na yung final answer natin. So from this one. Okay, so last one. So obtain the power series of tangent inverse of x from f of x is equals to 1 over 1 plus x squared. So first we will obtain first the power series expansion of f of x. Okay. So ito wala pa kasi tayo nito 1 over 1 plus x squared. So sinabi sa problem, take mo daw yung series expansion ng tangent inverse of x from this series. Kasi the problem wants us to use the third basic operations, yung the integration. So kailangan niyang mapakita that the integration of f of x is simply the same as the integration of that polynomial. Okay? So ayan. So first, obtain muna natin what is the Taylor series expansion of 1 over 1 plus x squared. So if we recall this one, palitan mo lang yung, simplify mo lang yung 1 over 1 plus x squared ng 1 over 1 minus negative x squared. Okay? So ayan na siya. So naging negative x squared raised to I summation from I equals to 0 to infinity. Okay? Then this one, simplified version, copy mo lang, hiwalay mo lang yung negative 1 raised to I and x raised to 2I. Okay. So as we all know that the integration of 1 over 1 plus x squared is simply arctangent of x. Okay. So integral of tangent of negative x is equals to 1 over 1 plus, sorry. The integral of 1 over 1 plus x squared is equals to tangent inverse of x. Okay, if you all know, if you recall the integral, your integral calculus. Okay, so this one, so tangent inverse of x is simply the same as the integral of 1 over 1 plus x squared dx, or equals din siya sa integral of its power series expansion. Okay, so taking the the integration, so the only integration lang ang the only term na pwede mo lang integrate is yung may x. So ang pwede mo lang integrate dito is this one. Okay, so ano nga ba yung integration ng x raised to n dx? That is simply x raised to n plus 1 over n plus 1 plus c. Okay, if you recall, that is the integration for x raised to n dx. So x raised to n plus 1 over n plus 1 plus c. So therefore, x raised to 2i is simply x raised to 2i plus 1 over 2i plus 1 plus c. Then copy negative 1 raised to I. So may plus c ka dito. May constant of integration ka. Okay. So using this one, so substitute mo lang at x equals to 0, c is equals to 0. Kasi if you substitute dito, okay, if you substitute mo x equals to 0 this term, so tangent inverse of 0 is equals to 0. Okay, this one whole term will be 0 again. And c, this one, kasi substitute mo dito 0. 0 raised to I plus 1 is simply any number raised to 0. 0 raised to any number is 0. So 0 to. So therefore, c is equals to 0. Okay. So we can say that x raised x at x equals to 0, c is equals to 0. Therefore, the constant term of integration will be cancelled, and the only term is the tangent inverse of x is simply summation of negative 1 raised to I, x raised to 2i plus 1 over 2i plus 1 from 0 to infinity. So that is your final answer for obtaining the power series of tangent inverse of x. Okay? So next natin is obtain the power series of x e raised to x. Okay? So recall that e raised to x is this expansion. So x multiplied by e raised to x is this one. So pwede ka rin mag-multiply ng ganitong function. So x, okay? So x raised to I times x over I factorial, that is this 1. So therefore, that is, okay, ito. So that is x raised to I times x, that is x raised to I plus 1 over I factorial. So pwede kang mag-multiply ng x dito sa common integration mo. So para kang magmumultiply lang dito, x e raised to x is simply summation of I equals to 0, infinity, x raised to I over I factorial. Okay? So pwede mo siyang i-multiply sa loob. So therefore, that is x raised to I plus 1 over I factorial. Okay? Now, enough for Mclaurin series. So, Taylor series expansion naman tayo. So, for the Taylor series expansion, the same lang din yung process. However, this time, meron tayong centered value. So, meron tayong A. Yan. Kasi nga, ang A natin dito is not equals to 0. Okay? So, first problem is this one. Evaluate f of x is equals to sine x in powers of your pi over 2. So, dapat daw ang makita niyang powers is all terms that is pi over 2. Dapat naka-pi over 2 lahat yung x to this one. So, x minus a, dapat daw naka-pi over 2 to. So, dapat naka-pi over 2 all terms. Okay? So, yan yung ibig niyang sabihin. In powers of pi over 2. Okay. So, therefore, so if we check dito, so therefore, we need to find pi over, what is the value of a muna natin. So, since the Taylor series expansion is x minus a raised to I, so therefore, sabi niya, dapat powers of pi over 2 lang yung makikita niya. So, x minus a, ito pala, meron na ako nakasulat. So, x minus a is equals to x plus pi over 2. Then, substitute, a will be negative pi over 2. So, what is the value of a? That is negative pi over 2. So, therefore, that yung power series expansion natin is centered at a is equals to negative pi over 2. So, if you recall the Mclaurin series for sine of x, this one is ito. Ito yung Mclaurin series niya eh. Diba? Okay? However, hindi mo siya pwedeng gamitin kasi magkaiba yung center nila eh. Center dito 0, dito naman negative pi over 2. So, pinakita ko lang dito para ma-compare natin. So, using a traditional solution, you will find a pattern, okay? The same way. So, f of x, f prime of x, f double prime of x, and f triple prime of x. Okay? So, f fourth of prime, nakakita ka na ng derivative dyan, ng pattern dyan eh. That is sin x na ulit. Okay? So, according to the expansion, substitute mo yung value of a since ith derivative of a. Sorry, f prime of a, di ba? Substitute mo yung value of a. So that is negative pi over 2, negative pi over 2, negative pi over 2, negative pi over 2. So the pattern will be negative 1, 0, 1, 0. So nandiyan negative 1 again. So ito na siya. Ito na. So papasok mo siya dito sa sign sa Taylor series expansion. So ganun lang din. So Taylor series expansion, this one, that is simply f of x is equals to f of a over 0 factorial x minus a raised to 0 plus f prime of a 1 factorial x minus a raised to 1 plus f double prime of a 2 factorial x minus a raised to 2. Okay, and so on and so forth. Okay, so pasok mo lang natin siya dito. That is simply -1, but is a value of your f of a, -1 x plus pi over 2 raised to 0 over 0 factorial plus 1 over x raised plus pi over 2 over 2 factorial. Okay, -1 x plus pi over 2 over 4 factorial plus 1 x plus pi over 2 over 6. Kasi nga yung mga odd numbers is nakakancel kasi ito 0 0. So what you have left is ito 0 2 4 6 8. Okay? Yun na yung natira. Okay? So if you see a pattern, meron kang pattern na nakita, -1 1, nag-start sa -1 1 -1 1. So therefore, if you check yung recall sa preliminaries natin, that is -1 raised to n plus 1, starting at n equals to 0. Okay. So since nag-start ka sa n equals to 0, pati syempre gamitin mo na rin dito sa ano mo, n equals to 0 din. So if we use our arithmetic series, so series 0 to 4 6, that is simply 0 plus 2i. So 2i lang yan. So pwede mo na siyang i-rewrite. So -1 raised to i plus 1 x plus pi over 2, yung powers mo is naka 2i over 2i factorial. So that is sine of x. Sine of x, Taylor series expansion at a is equals to -5 over 2. Okay? Sorry. So if we compare this Taylor series expansion and the Mclaurin series expansion, magkaiba sila. Yan, magkaiba sila. So hindi mo siya pwedeng gamitin doon. Okay. So next problem is find the Taylor series for y is equals to cosine x at x equals to pi over 2 naman. So hindi niya na sinabi in powers of pi over 2. Sinabi niya exactly x equals to pi over t. Or simply a. Sorry, bakit x to? Dapat should be a is equals to pi over 2. So by the Taylor series expansion, that is this form. Okay, then find the pattern. F of x equals to cosine x. For the first derivative, negative sine x. Second derivative, negative cosine x. Third derivative, sine x. Fourth derivative, cosine x. Yun, bumalik ka na. So you have your pattern. So f equals to pi over 2. Pasok mo. Pi over 2, pi over 2. Ito yung pattern na kuha mo. Okay, then substitute to your Taylor series expansion. Cosine x is equals to, by the Taylor series expansion, that is f of 0, f of a over 0 factorial x minus a raised to 0 plus f prime of a 1 factorial x minus a raised to 1 plus f double prime of a 2 factorial x minus a raised to 2 plus so on and so forth. Okay? So if we substitute this all this term, this one, okay, ganito yung natira. So all the sorry, all the even numbers are 0. Yan na 0 to lahat. Okay, so masi-0 dyan, 0, 2, 4, 6, 8, 10. And what you have left is 1, 3, 5, 7, 9, mga ganyang powers. Okay. So the patterns will be this one. Ano yung pattern natin? So starting from n equals to 0, kung nakita mong pattern, -1, 1, -1, 1, -1, 1. Therefore, that is -1 raised to n plus 1. Okay. Then nakita mong pattern that is the powers is 1, 3, 5, 7, 9. So nagawa na natin yan. That is simply 1 plus 2i. Diba? So pasok mo na lang siya dito. So that is simply dito. Ito. So that is -1 raised to I plus 1. Ito yon. Okay. Then this one is x minus pi over 2 raised to 1. Okay, yung 1, 3, 5, 7, 9, ito yung pattern niya. That is 1 plus 2i. Sa ilalim niya is the same. That is 1 plus 2i factorial. So simply the Taylor series expansion at centered at a equals to pi over 2 is this answer. For cosine x is this answer. Okay, so for your homework class, evaluate the power series expansion of your e raised to t over t. evaluate the power series expansion of e raised to t over t dt, integral of e raised to t over t dt. And number 3, evaluate the power series expansion of e raised to t over t dt evaluated at 2x x to 2x. So hint, after solving your problem 2, evaluate the integral from a to b in t. Okay? So yan lang. Kasi after mo matapos to, after mo ma-solve tong e raised to t over t, substitute mo na lang yung evaluate mo na lang yung integral from lower to upper boundaries in t. So that is all for the Taylor series, for the power series expansions. So do you have any questions, class? Sorry, hindi ko nalagay yung duration. So duration na ito, same pa rin next Wednesday. Next meeting. Okay? Sige. Do you have questions for this topic before we end?
None po.
Okay. Sige. O yan. So, that's all for today. So, mamaya, exactly 10:30 we will discuss. Gusto nyo ba discuss na natin ngayon? Kayo rin yung Wednesday, wala naman kasing sa Wednesday class kasi, wala kasing tawag dito, walang naka-enroll sa LEC lang or naka-enroll sa lab lang. Kasi all the students is LEC and lab. Ano bang gusto nyo? Kaso, wala pa yung iba eh. Hindi tayo kompleto eh. Sige, 10:30 na lang. Pasok kayo ng 10:30 sa lab. Sige, class. Bye.